Hello. In this example, we're going to start talking about the Gauss-Jordan method. Now, the Gauss-Jordan method is a technique that uses row operations to transform a matrix into what we call the reduced row echelon form, with ones in the diagonal and zeros above and below the diagonal ones. Calculator instructions are located in the notes. Now, here's the thing. When we talk about the Gauss-Jordan method, by the way, this is Gauss, it's not Gauss. It's Gauss-Jordan. Technically Jordan, I think, but yeah, we're going to ignore that. Anyway, when we talk about Gauss-Jordan, we're talking about what we call the reduced row echelon form. And in the calculator, or when you see this, you should think of using the calculator and using RREF to get the solution. So anytime it says Gauss-Jordan, that's what we're trying to do. And let's talk about this form that we're talking about. Okay, so if I had a matrix and I said that the matrix was A, B, C, D, E, F, this is an augmented matrix here. If I was to put this into what we call the reduced row echelon form, the new matrix would then look like this. 1, 0, let's call it smiley face. It looks too much like a 0. Let's call it alpha, and 0, 1, beta. Now, what's important is that the diagonal, let's use a different color here, the diagonal is just this. It's a diagonal here. In other words, this element is the first row, first column element. This element is the first or second row, second column element. And if we had a third row, it would be the third row, third column element, and so on and so forth. In other words, to be on the diagonal, the row number and the column number needs to be the same. Otherwise, it's not on the diagonal. Okay, and with this, it says zeros above and below the diagonal ones. So if we have a 1 here, everything below that has to be a 0, and a 1 here, everything above that has to be a 0. Now that's for a 2 by 3, and let's look at a 3 by 4. So if we had A, B, C, D, E, F, G, H, I, J, K, L, like this, notice that this would be a 3 row, 4 column. Using reduced row echelon form on this one would look like this. 1, 0, 0 alpha, 0, 1, 0 beta, 0, 0, 1 gamma. And again, notice that the ones are all on the diagonal. Excellent. Well, there you go. This is reduced row echelon form for a 3 by 4. This is the reduced row echelon form for a 2 by 3. Now, we need to talk about how we use this information. So let's use our calculator to solve the following system of equations. Write the system as an augmented matrix and write the reduced matrix. Then express the solution as an ordered pair. Okay, first of all, notice that there are two equations and 2 different variables. That means that we're going to have something that looks like a, come on now, there we go, a 2 by 3 matrix. So what we need to do is we need to convert this into an augmented matrix. And this one as an augmented matrix, I'm going to start out with the capital letter A, would look like 2, 3, 7, 3, -4, -32. And notice that all I'm doing is I'm getting rid of the x's and the y's and the equal signs. And technically any of the pluses. And there you go. That is the original form. That is what I'm going to label as the initial form. Next, I need to write down what the reduced row echelon form is going to look like. To do that, we're just going to use the calculator. We could do it by hand, and if you want to come take my 1414 class with me, we will do it by hand in there as well. But we'll also do it by the calculator because, well, frankly, it's helpful. And so I will see you in the calculator. See you there. Okay, welcome to the calculator. And to do this, we're going to have to start working with matrices. And on the calculator, over here on the left-hand side, do you see this x to the negative 1 button? That right there is where our matrix lies, because if you look at that, it says matrix right there in blue, and blue means the second button. So we're going to click second matrix. And notice I've got a list of matrices here. There's nothing in any of these, but you may or may not have any listed over here. That's fine if you do. There's nothing wrong with that. And we're not going to click on anything here. We're going to click on Write to edit. And notice that we want to edit matrix A, so click Enter for A. And the first thing we need to do is we need to write down the size of this matrix. And if you realize our matrix had 2 rows and 3 columns, so this would be a 2 by 3 matrix. Now, I just clicked 2 enter, 3 enter. You don't have to do the X, so just 2 enter, 3 enter. And now notice that the matrix just has a bunch of zeros where you need to, write down some numbers. So let's write these down. And the way we write these down is left to right, top to bottom, just like you read a book. So we're going to type in 2 enter, 3 enter, 7 enter, 3 enter, negative 4 enter, and negative 32 enter. Now, here's the thing. Some of y'all probably had an error here because instead of doing a negative 4 or a negative 32, you probably did a minus. And notice what it says when I click enter. It gives me a syntax error. Let's go to, instead of quitting, it's telling me that that's wrong because it's not, in order for the calculator to use a minus, it has to have something in front of it. So it's technically a negative sign. So this negative and this minus are 2 different buttons. So just be aware of that. And now if I click enter, it works out just fine. Fantastic. Now I'm going to go ahead and quit to the home screen. And to do that, just press second mode. And the mode is just right next to the second button. Notice it says quit above it. And just doing second mode should be second nature to you because this takes us back to the original screen. Now let's go back into matrix. Think for yourself how to get back into matrix. Good, you have second and then x to the negative 1 here. Now notice that on this A, I have something new. It says 2 by 3. That tells me that there is a matrix already in there for A, and it's that 2 by 3 that we typed in. And again, we don't want to do anything here yet. We want to go ahead and go to math. And then go up until you see RREF. Double REF. There is an REF that stands for row echelon form, which is a little bit different. We want the double REF. Click enter. And notice that on the home screen now, we have RREF parentheses. Now, this is wanting us to talk about what are we wanting to take the reduced row echelon form of. In other words, this is an operation that needs to perform. So it needs something to perform it on. So let's go back into matrix. And now is when we click on enter for A. And you can click enter again, or you can close parentheses, that's fine. And then click enter. And fantastic, there is our solution. So it's 1, 0, negative 4, 0, 1, 5. I'm just writing that down on the paper. So 1, 0, negative 4, 0, 1, 5. Okay, good deal. So that's pretty much how you use reduced row echelon form in the calculator. By the way, if you go back into matrix, if you press delete, it doesn't do anything. You can't get rid of that. Even if you press clear, it just takes you back to the home screen. And second matrix, it's still there. So the question a lot of people have is, how do you get rid of the matrix? Well, here's how. Press second And then this little plus button is memory. And then we want to go to memory management, which is 2. And we're talking about matrices, so 5. And notice that I now have A listed with the 65 there. That's the size of this. Well, it's the amount of data that matrix A is taking up. So to get rid of it, you don't want to press clear, you want to press delete. So if I press delete, it's gone. So going back, second quit, go back into matrix, and notice that that 2x3 is gone. It's no longer in the calculator. Alrighty. Well, in that case, I will go ahead and see you back in the notes. Okay, welcome back to the notes. Let's go ahead and finish this up. We now have the initial matrix. We have the reduced row echelon form of that matrix. And now we need the solution. Well, here's the thing. The solution just comes from those numbers there. And the solution needs to be in the form of xy. And it's just going to be -4, 5. In other words, when you have the system like this, your coordinate is this. Or for this one, the ordered triple would be this. In other words, whatever order it is here is the order in which it needs to appear here. So -4 first, then 5. So -4 first, then 5. Alrighty. Well, that's pretty much it for this example. I'll see you in the next one. Have fun.